right, kiddos. Hi, how we doing? Happy Friday. It's a Friday in science class, which means we are taking a root word quiz. So please go to root word quiz modules. You're going to go to root word quiz week 4, and your code is ultraviolet, like the UV rays, but it's ULTRAVIOLET. That is your code. Make sure you take your root word quizzes or quiz week 4. It should be very short. Remember, no notes and no Googling. Read that root word quiz. All right, let's get on to your assignment for today. So we are going to review those Cornell notes that you should have taken yesterday. Remember, guys, note-taking is a super important skill that you will need with you all throughout your rest of 5 years that you have in school, and definitely when you go on in college. So you needed to read pages 36 through 38, which you really have already read before. So now we're ready to take notes. So it should look like this, right? That's where we're looking on your ebook. So please, I want you to follow along with me so you can see. I'm going to show you how I took my specific notes so that way you know what's going to be important to pull out. We're going to practice pulling out information that we need from the reading. So our first reading that we have here, we're going to start with explaining chemical reactions. So right away, guys, I see that this is a special heading. It's in different color and it's bigger than the rest of the text. So I know I want to make that a heading in my notes. So right away, you'll see on Canvas, I had you title your notes chemical reactions, and you set it up in Cornell form. So right away, I have made my own heading for explaining chemical reactions because I see this heading on page 36, explaining chemical reactions. I know that the information that I'm going to put now under that has to do with explaining chemical reactions. So you want to go ahead and we're going to read the information. I'm reading on page 36 right now. You might wonder why chemical changes produce new substances. Recall that particles in matter are in constant motion. As particles move, they collide with each other. If particles collide with enough force, the bonded atoms that make up particles can break apart. These atoms then rearrange and bond with other atoms. When atoms bond together in new combinations, new substances form. This process is called a reaction. Chemical changes often are called chemical reactions. So I wanted to see what were the main ideas. What do I want to pull out of that reading? Because I don't want to put that whole paragraph in my notes. I just want to know what do I think is super important. So what I wrote is chemical reactions are when atoms bond together in new combinations. And you'll see at the bottom, I put chemical changes equal chemical reactions because I know with those symbols, I'm going to know that whenever I see a chemical change, I'm going to think of a chemical reaction. And RXN is a way that you can abbreviate reaction just so it's less writing that you have to do. And that's it. I was able to summarize up that whole paragraph in 2 bullet points. And remember, at the end, you want to go back over your notes and you want to see what are some questions that maybe your teacher might ask you, or what are some notes. So I want to say, why are chemical formulas useful? Because the next heading in your book, it's in blue and it says using chemical formulas. So I know my next chunk of notes is going to be, or are going to be, about chemical formulas. So let's read. Using chemical formulas. A useful way to understand what happens during a chemical reaction is to write a chemical equation. A chemical equation shows the chemical formula of each substance in a reaction. The formulas to the left of the arrow represent the reactants. Reactants are the substances present before the reaction takes place. The formulas to the right of the arrow represents the products. Products are the new substances present after the reaction. The arrow indicates what reaction has taken, or that a reaction has taken place. How did I sum all that up in a couple of bullet points? Well, I wanted to remind myself that chemical equation shows the chemical formula of each substance. And remember, you don't always have to have correct English. Your notes are just quick jot down for you to remember. And then again, I did that RXN because it's less time to write that. Now, here's where I was really able to cut down on a lot of text. Instead of more, my book said, the formulas to the left there represent the reactants. Reactants are the substances present before the reaction takes place. I just simply wrote reactants, arrow, products, right? So I just showed myself with a little chart where the reactants go and where the products go in a chemical equation, and then I defined each of those terms right under it. I also highlighted it because I thought that was pretty important. I saw that your book took about a third of a page to explain it and had a paragraph for it. So, and then I arrow indicates that a reaction has taken place. It's also called a yield arrow. Now, moving on to the bottom, I read through the balancing chemical equations. Again, I saw that this was its own heading in the book, so I wanted to make extra sure that it had its own spot. Now, I read through all of this and I pulled out the important parts. After I read through the balancing chemical equations, I pulled out the facts that equations must follow the law of conservation of mass. Now, I know what the law of conservation of mass is, so I didn't write that law down. But if you do not know what it is, go ahead and write it down. Matter can neither be created nor destroyed. So that means that our reactants, our number of atoms on our reactants, has to equal the number of products. Now, right now, I just did that intro activity yesterday to just see how we did with balancing equations, but you really don't have to balance those equations on the test. You just need to know that the reactant numbers must equal the products numbers. So I also read through and I said I can change the coefficients to change the amounts. So I can change the number that goes in front of a molecule, but I can't change the formula of the molecule because that would change the substance. I can only change the coefficient. And then remember, at the end, you want to summarize up what your whole notes just said. So my summary is, chemical formulas show and explain what is occurring in a chemical reaction. And it shows products are formed from reactants. I just pulled out what I thought was important and summarized it up in one sentence. And then the whole balancing chemical equations green part, I just left out of my notes. And then I went to the next section in your book. Again, much like I did before, I saw that rate of chemical reactions, I'm on page 38 now, is red and bolded, so I figured it's probably going to be important, so I made it a heading in my next page. Then I read that paragraph. From there, I pulled out that different factors can make particles move faster, collide harder, and more frequently, which increases, because I did a little arrow, their reaction rate. I noticed that they talked here and in the beginning of the section about particles colliding, and that's and bumping into one another, and that's how reactions happen. So I felt that it was important for me to include particles in my book, or in my notes. So that's how I got that. And then 1, 2, 3, I just really quickly went over the 3 factors that they said can increase the rate of a reaction. Temperature is one of them. I don't need to explain what temperature is to myself because I know what it is. So all I said was what temperature does to the reaction. Increased temperature, increased rate of reaction. Concentration. Now, that's a vocab word, and so I want to highlight it. And also, it's kind of confusing. So I went the extra mile, and I looked up the definition in my book, and I learned that concentration, otherwise known as the amount of substance in a certain volume, how much of it is in there. So when concentration is high, there are more particles available to bump into one another and react. I know that they're bumping into each other, that increases the rate of a reaction. So if there's more of them, that's going to make it increase. So again, I defined what it was, but then I also said how it helps or how it changes the rate of chemical reactions, because that's what we're talking about in general. And then last but not least, I talked about surface area, and I just kind of summarized up what the reading said. More surface area means more space available for reactants to collide, which will increase it. And look at that. You always want to go over your notes. Will increase reaction rate. So again, remember, you want to pull out some potential questions that you think I might ask you. So a question that I pulled out was, how do temperature, surface area, and concentration affect the rate of chemical reactions? Because if your book took a whole page to describe it, it's probably important. Last but not least, we summarize this up. The rate of a chemical reaction depends on how fast, hard, and often particles collide with one another. Different factors can speed up or slow down reaction rates. So there you have it. You had 3 full pages in your textbooks, and we were able to break it down to just a page and a half in notes, and it includes everything that I think may be important. So as long as you follow through this video and your notes are good and up to date, go ahead and take a picture of your Cornell notes today and submit it as your assignment. If you want to take your picture after you've gone through this video with me and update your notes a little bit better, that's fine. Or if you want to do it before, if you're happy with your product that you have and you feel like you don't have to make any improvements to it, you can just take a picture as it is and upload it to this assignment here on Canvas, and then you're all set. Have a great weekend, guys.